Hello everybody, welcome to this new tutorial. If you have been following the series, you saw that last time we created a system to draw shapes to the screen. Pretty cool, huh? So this time I'm going to process the input to make the player control a shape with the keyboard. Now if you're not caught up with the series, you could watch them on YouTube and download the source code on the link below. Okay, let's get started. Firstly, let's just understand how input works. As you may remember from the previous tutorials, inside our game loop, we see all the messages that Windows sent us. And these messages include things like input. So right here, we can process the WM key up and key down events. And we're going to move the translate and dispatch messages only in the default case. Now we need to extract two things from this message. First of all, we need to know what key the user pressed. And secondly, since we are processing them together, we need to know if it was a key up or a key down event. And we can just extract it from the message struct. Now how are we going to save the button state? We need to make it very easy for the game to use. That's the top priority. Something like if pressed, button up, or if is down, button down, things like that. Now let me quickly draw the possible states for the buttons and a cool solution as well. Now let's say that for some frames the button is up, so the user is not pressing it. Then the user presses it for a few frames, then it releases it. We are interested in three situations. First one is when the user pressed, so we need a single frame of event. Another one is when the user released, because we may want to do something in this case. And a question whether or not the button is down at this frame. So we can right off the bat just say if the button is down in this frame, which is going to give us the is down information, right? But we can also save if the button changed from last frame to this frame. See that in this case, only in 2 frames it would have changed. And if it changed and the button is down, means there was a press event. And if it changed and the button is up, means there was a release event. With these 2 variables, we can get all the 3 events that we want for the button. Okay, so let's do this. I'm going to create a new file because this code relates to the platform layer, but it's not specific to Windows because all platforms will translate the buttons from their system, which use a message loop and things like that, to our system, which is the is down and changed variables. I'm going to create a button state struct, which will hold, like I said, a is down variable and a changed variable. And let's just enumerate which buttons we care about. For now, we're going to do up, down, left, and right. And the input struct will just be an array of buttons. Now you could hardcode for here, but we have to remember to change that every time we add a new button. A nice little way that we can fix it is to make sure that the last button in the enumeration, something like button count, then we can use it to create the array. And also iterate that when it comes time. Okay, now let's fill that information. Let's just do one button for testing. I'm going to switch from the key code, and if it's VK up, which is the up arrow, I'm going to set the button up item in the array is down to is down. And it changed to true because we just received a message, right? We also have to create the input struct. I'm going to zero that out. And I also need to reset the change in the beginning of every frame because we only want the change to last 1 frame. So whenever we start a new frame, we're going to run through all the buttons and set the change to false. Nice. Now I'm going to include the file, right? Okay, now let's do just some testing to see if we have the input information. If the up arrow is down, we're going to draw the center rectangle. Okay, so it's not there. And if I hold the up button, it's there. Perfect. Now let's clean this up a little bit and move this to a game file. The platform will just call the simulate game function, and the game will do whatever it wants, and it should also pass the input. Now I can exclude both these files from the build. And I should also include the game. Okay, let's see if we have the same thing. We do, perfect. Now, like I said, we want an easier interface to use the input. We don't have to type like input, button, array every time. For that, I'm going to create a couple of macro helpers. The first one, we'll just test to see if the button is down. So it'll be super easy to use. Now to know if the user pressed the input, we're going to test to see if it's down, and it changed. And the release one's same thing, except it's not down. Now let's test them. We're going to make a position variable. And if the player pressed the up button, we're going to increment that. Now let's see. Awesome. Now let's do the full input now, shall we? Now you could copy this whole piece of code here. That would be really big and messy. We can make a helper macro that we can call instead. Okay, let's see if it's still working. We are, perfect. Now it'll be really easy to add the other ones. Isn't that awesome? We can already make a small game with this, right? Now let's try making the input contiguous. So for as long as the player is holding the button, the square is going to move. Now there'll be a couple problems with that. Oh, first of all, it's too fast. Yeah, it's kind of okay. Let me show you something. If I make the game full screen, we are really slower. Why is that? Well, before, this number was being added every time we hit the button. But now, it's how much we're supposed to move in one frame. So we are moving 0.5 units per frame, which means that the higher the frame rate, the more we're going to move. And when we make the screen really big, we have to process a lot more pixels, and that made the frame rate slower, and the player as well. And that shouldn't happen. So what we need to do is have a way to make this number express in a frame rate independent way, like units per second. Now how are we going to do that? So right now this is units per frame, and we need that to be units per second. Well, if we multiply that by the seconds per frame, we'll be able to transform that in units per frame. Perfect. But how do you get the seconds per frame? Well, players love talking about the frames per second because it usually coincides with the refresh rate of the monitor, like 60. But for us developers, it's way easier to discuss time in a seconds per frame manner. For instance, 60 frames per second would be 0.016 seconds per frame, or 16 milliseconds per frame. 30 frames per second would be 33 milliseconds, and so on. It's really easy to convert one to another. And discussing things in seconds or milliseconds per frame instead of frames per second have another advantage. Let's say we just optimize our game, and we manage to get 5 more frames per second. Is that a good optimization or a bad one? Well, it depends. If the game was running at 10 frames per second, we got it running 50% faster, which is crazy. Now, if the game was at 1000 frames per second, we barely even changed the speed. Now, if we discuss the same thing in milliseconds, like we improve the game 10 milliseconds, we'll see if that's great or not, no matter what the current frame rate is. But how do we get that information? Well, we can ask Windows what the counter is, which is the unit in CPU time of the current time. So if we get one in the beginning of the frame and another one at the end, and subtract them, we're going to see how much time passed in one frame. And we just need to convert that unit from CPU cycles to seconds, and we'll get how many seconds per frame. Now let's program this. Right before we start the first loop, we can create a delta time variable, which stands for how much time elapsed in one frame. And for the first frame, we're just going to assume it's 60 frames per second, so 0.016. And we should also get the CPU time. To get this, we're going to create a large integer variable and call the query performance counter function, and pass a pointer to it. Now if we get that counter at the end of the frame, and subtract the 2, we should be able to get the difference. but it's not in seconds yet. Remember that these functions work on CPU time? So I'm going to have to call the query performance frequency function. This function returns how many cycles the CPU can run in 1 second. So if you divide the subtraction by the frequency, you'll get the delta time in seconds. The last thing we need to do is just to say that the begin frame time is now the end time, to start the new frame. Now I'm going to run with Ctrl F10 just to debug and see if we are correct. So this was the timer when we finished the frame, and this was in the beginning. If I get the difference, it's 13,000, so that's the amount of time in CPU time that passed. Well, the CPU runs this huge number, which is 3.2 gigahertz, in 1 second. So the delta time is 0.0041, which means that this first frame took 4 milliseconds to execute, which gives a frame rate of 250 frames per second. Not too bad. And that's the debug build. Remember that? Means that our code's running really slower to give us more information to debug. And if you ship that to the player, it's going to run way faster. Okay, so now with that information, we can pass that to the game. And if we multiply this value with the dt, we'll be able to express our speed in units per second. That's perfect. Now let's see if we have a consistent speed. Okay, pretty cool. Now let's make it full screen. This is perfect. It's the same speed. Apply the different scales, of course. But if you make that really small, which means that the game should run at a very high frame rate, you have the same speed, takes the same time to get from one square to the other, right? Perfect. Now our engine is ready to start building the game. And that's what we're going to do in the next tutorial. You can already play around with this quite a bit, and I'm going to give you a challenge for you to do before next tutorial. Try making a button that when the user is holding it, increases the speed of the player. That'll be pretty cool. So make sure you're all caught up, because next time I'm going to do a better movement, doing acceleration and deceleration, and I'm going to actually do the gameplay of the game, okay? I hope to see you then. Bye.